Project Secret is set to investigate physics of leakage flows in clearances of rotary positive displacement machines by numerical and experimental means, and to develop concepts for new generation of efficient and reliable screw compressors for Howden, which will help to achieve challenging net zero targets defined by UK government. We are extremely grateful to the Royal Academy of Engineering for giving us opportunity to work on this challenging task. Using rigorous design process, we have defined 4 areas where the new concepts are being developed. As a part of this process, the team came to an idea for discharge valves in oil-free screw compressors and submitted patent application for this solution.
Phase 2 of Project Secret has provided the team with a clear roadmap of how we can develop the initial research findings of leakage flows and heat transfer effects in oil-free compressors. The collaboration between the Howden and City University teams has grown into a fully formed relationship with the relative skills and experience being freely shared, and for me that is the #1 success so far, which will stand us in good stead for Phase 3.
I'm very proud to be mentoring this world-leading Royal Academy of Engineering Research Chair between Ahmed at City University and Howden Compressors. The project has been a great example of academic industry collaboration that has been enhanced by Royal Academy of Engineering funding and under great leadership. The research will revolutionise oil-free rotating compressor design that will reduce energy consumption and improve reliability, thus enabling meeting net zero requirements. The project has short and medium-term and long-term development strategies that cover test facilities, validated numerical methods, scaled-down compressor prototypes with novel rotor profiles and smart clearance management system, and an industrial prototype with integrated remote monitoring and self-regulating systems. After 2 years, and despite being faced by challenges imposed by the pandemic, the project is on track and further funding and global reach already secured.
In the next year of the project, we will complete and validate new concepts using our state-of-the-art test rig. This will require building new prototypes.
It becomes more real for us at Howden when we see the theory outcomes being validated in a test setting. Even though we will only be halfway through Project Secret, from there I see us quickly transferring this knowledge into our core compressor design and test methodologies.
In Phase 2, I'm pleased to say we have successfully connected the 2 City University laboratory control systems to the Howden Uptime platform, where we started to remotely monitor the operations.
Work Package 2 is dedicated to the measurement of velocity field and temperature field in the leakage gaps of roots blower experimentally. Findings from PIV results are leading us towards the use of specific geometry on the rotor tip to reduce leakage losses.
Work Package 4 focuses on numerical investigation of the effects of heat transfer on leakage flows. We have currently developed a CHT model of a Howden roots blower, and test results obtained from infrared thermography have been used for validation of the results obtained. In Phase 2 of the project, 3-dimensional CFD models that are currently in practice were extended to include heat transfer to and from the metal components of the compressors. Validated numerical models thus give us a baseline condition which can then be used to perform design changes and evaluate conceptual designs with reliability. How these changes will influence leakage flows and the overall compressor performance and operation can be answered prior to building a real prototype.
Work Package 6 is dedicated to the development of a clearance monitoring system that can be used to collect data in operating conditions. During Phase 2, a range of instrumentation technologies were reviewed and a series of concepts were assessed against the system requirements. The review supported a concept in which displacement probes and fiber Bragg gratings were combined as an effective way to collect a large set of data for analysis of the transient phenomena. In the next year, we will develop the concept and integrate it into the compressor test lab for experimentation. The data we collect will help us understand the behavior of these clearances during transients, and we believe this is critical to improving reliability and efficiency of these machines. With a monitoring system in place, it also becomes possible to actively control these clearance gaps with corrective actions.
Work Package 7 aims to develop new concepts to improve efficiency and reliability of oil-free twin-screw compressors.
The active bearing concept looks at control of clearances using the hydrodynamic bearings. By controlling oil supply conditions to the bearings, it's possible to alter the position of the rotors as a way of controlling clearances. Work to date has been to analyse the bearings currently used in Howden machines to determine how much control over the rotor position is available.
One of the concepts we are developing is how to incorporate active control systems to protect the compressor and improve performance. With the novel monitoring systems that will be implemented, we believe we can find ways to control clearances and minimize leakages.
The concept of replacing screw machines' discharge port with reed valves will help improve their reliability in transient conditions by automatically matching the machine's internal volume ratio to the system.
This concept variant is about the use of tip features which can help to reduce the leakage losses. This will lead to design and selection of the rotor tip shape which can contribute to leakage flow reduction without reducing clearance gap.
This Work Package 8 leads to a fully operational test rig utilized to test a prototype compressor in an extensive range of operating conditions.
My role at City is to allocate appropriate technical support. We are fortunate to have a number of highly skilled staff at our disposal, operating in a workshop including a number of CNC machines, cylindrical and surface grinding and welding.
My role here is to manage the administrative work and the recruitment, marketing of the project. In the previous year we put a lot of effort to promote the project through our social media pages and as well as dedicated web page for the Project Secret, recruiting the new PhD students in the past year. We plan to continue with marketing of the project because we found out that this is very important both for the city and for Howden as well as the Royal Academy of Engineering.
Innovation needs marketing, and my main objective is to deliver a robust marketing plan that supports and amplifies the fantastic work of this project. The main goal is to grow the project and product awareness. My focus is to convey the key benefits and technological advances of our Howden oil-free screw compressor technology. This project demonstrates the strong collaboration that Howden have with our partners at City University and the Royal Academy of Engineering, and is truly special as it combines academia with industry to apply theoretical principles into proven and tested design, which in turn advances technology that has both physical benefits and strong commercial viability. This is exciting as I get to work with a team to celebrate all of our successes with the wider world. The true essence of this project is about transformational change, both in engineering and manufacturing processes, but also to develop novel compression technology to support our energy transition and our race to net zero. It is rare to be offered an opportunity to be part of a team that will produce positive change and impact for decades to come.
At the end of the 2 years, I expect to have a clearance measurement system in place with repeatable, accurate results and connected to a system that will be able to guide users on how to optimise the clearance in terms of efficiency and reliability.
In the short term, Howden will implement some of these concepts like regulation of clearances and control mechanisms in their oil-free screw compressors. In the long term, new machines will be designed with superior performance and increased reliability, which will ultimately result with a shift in the market in the use of oil-free machines. We believe that current 17% market share of oil-free screw machines will increase at least 10% in the next 5 to 10 years, leading to reduced carbon footprint and more reliable operation.
This is all about collaboration and sharing of ideas. We are in a transition phase from concept to validation phases in the project, and for me this will be an iterative process as we build our collective understanding of the outcomes and then transfer into a commercial reality. Beyond this, Project Secret has created a real excitement in Howden as we work with the Royal Academy and City University on leading edge technology. At Howden, for over 165 years, we've always prided ourselves on being industry leaders, and this is a continuation of that legacy.